Please start, sir. We are live.
Okay. So great. Welcome to the first meeting of Discrete Mathematics. We have with us Professor Neeldhara, who is also part of this the teaching team of the course. Me and Neeldhara are offering this course. Harshil and Saraswati are also here, who are TAs of the course. I was just wondering, is there anyone around from the audience side? Looks very silent. Okay. So great. Welcome to the first meeting of Discrete Mathematics. So I think I might have to reduce the volume of YouTube because there's some lag of 5 seconds and it starts playing there. Right. So if anybody is there, please feel free to ask your questions on the chat window, and we'll try to answer them here. All right. Otherwise, we'll go ahead. The first few minutes we'll try to give you an introduction to discrete math, how we see it, and why we think students should study it. By we, I mean the teachers. Okay, so discrete math, how I saw it as a student was it was probably a okay. So 1 second, YouTube audio we need to mute. Okay, done, bro. All right, so let's start. So yeah, how I saw discrete math as a subject when I was a student it was sort of, kind of easy if you have some math background. It's only aptitude questions, but then it troubled me quite a bit for a few years as to why we at all study discrete mathematics in computer science. And to my surprise, when I would read textbooks, each textbook would have a different kind of a preface or foreword on why they think discrete math is important. This confused me even further. And I realized that each author seems to have his own version of why discrete math is important. And I only later realized that it depends on us how we see computer science. And these different authors saw it differently. Right. So later on, I realized that with experience, I felt discrete math more or less is the sort of working principle for computer science, especially at the level of understanding how computing is done without emphasis on the computing device. Let's say this is how we introduce the subject to. If you have watched the first week of videos, there are certain see, be it language or be it physics or be it any science or economics or humanities subject too, you see that asking questions is sort of easy, but when you answer them, hand waving answer is also sort of okay, doable. But if you go one level deep into it, you get you see mathematics. All right, mathematics is mainly being organized thinking, and in computer science especially, people realized that from the Newtonian years, we have been teaching calculus, probably because that was important for engineering, other aspects of engineering. But computer science, we realized that for classical computing, calculus is not enough. Rather, it's not even required to some extent. But to a larger extent, we need numbers, arithmetic. Okay, we must understand. Let's say if an algorithm is running, we should understand when it will stop. Will it at all stop? Okay, so they realized that calculus may not be very helpful, and they devised their own bunch of the discrete ideas, seemingly unrelated. They took some 12 ideas and thought these things are important for computer scientists, computer science students to know, okay, computer engineers to know, and they made it a subject. That is one definition of discrete mathematics, the word discrete as I saw it. There's another meaning for the word discrete, which is it is the antonym, opposite of real line. Okay, discrete is integers, while continuous is your number line. Okay, now the real line. So with time, then people also realize right now that discrete math is necessary but not sufficient. With a offshoot of subjects like machine learning, artificial intelligence, the idea of deep learning, multi-layered neural networks, people realize that there is some sort of very advanced mathematics happening here, which even discrete maths cannot handle. So that is why there is some fine-tuning of mathematical prerequisites for computing happening right now. 10 years down the lane, I'm sure there will be more math for computer science coming up. All right. So that said, I would say there are two things that I would like to tip you people with. First tip is try to read the subject in its own right. Don't overdo the thinking process of what's the application of this, where do we use this, and things like that. This will come later. Okay. For instance, you tried the old school way of multiplying. You never asked the teacher for a proof of how this works, but then you sort of memorized it. But which time you realized how it works. So which time you will see all these things coming up, it's too early in the semester. Let's say this is generally taught in the first or second semester, at least at our IIT, probably third or fourth semester, third semester at many other places. But the applications will come next. You will be invoking it. It's like language. You learn the language, you can read any book. So we'll try to make you people read books, the prereq of which is discrete mathematics. All right. So this is tip 1, read it in its own right. Tip 2 is, there are several nice popular science books which I think people must read on the importance of discrete mathematics. All right, so I'll try to post them on the group sometime, maybe a bibliography of all the books. You can try ordering them and then reading them, and some of them might even be available online. They're classics. All right, okay, that's pretty much what I wanted to discuss. We will probably take up questions, before which I would like Neeldhara to address you all.
Hi, good morning, everyone. I think Sudarshan pretty much covered everything in terms of motivation.
I'm unable to hear. Vignesh, is everything okay?
I can able to hear them.
Yeah. So, okay, fine. Yeah, go on. I'm able to hear.
Maybe it's the YouTube lag. I mean, okay, hopefully you can hear on Zoom. I'm just trying to go back to the live stream and see if we have any questions so far. Okay, so maybe not yet. So yeah, I think I kind of just have to wholeheartedly agree with everything that Sudarshan has already said. I think, it's a beautiful subject on its own right, but it's also sort of some sort of a gluing mechanism for, ideas in computer science. The things that you learn in your discrete math course, they just come up everywhere, and at some point it becomes a part of your sort of second nature or bloodstream, so to speak. You'll say, oh, this follows by an averaging argument. You can do some pigeonholing here. You can do, maybe you can apply a probabilistic method here. That's going to work out because you can do generating functions, whatever it is. All of these techniques are super useful, but they're also super beautiful and worth studying on their own right as well. So yeah, I think these are early days in the course. Hopefully you already have a glimpse of, sort of the flavor of the ideas that are going to come through. These ideas will get more sort of sophisticated as we go along, but I think you can already get a sense of the fun that is involved, hopefully. Some of these things can sometimes be confusing, especially with counting problems. I remember being like sometimes a bit flustered about, not being able to figure out when are we really overcounting and when are we not. So one, again, small tip is to not hesitate to work with really small examples. Like sometimes I feel stupid working with like really silly examples, things that look like edge cases or examples that don't seem to have any content or depth, but it really helps clarify. Just build out a few small examples. I think it's nice if you're comfortable with some, even if it's a very simple language like Python, or it could be something like that. But if you're comfortable writing small scripts, you can generate a lot of examples, look at patterns. So when you're, working with a problem that leaves you feeling a bit that feels a bit mysterious, I think it's worth even resorting to a little bit of automated example generation if the small ones aren't already helping. So definitely work with examples to identify patterns, and to whatever extent possible, just try to understand a particular situation with as much clarity as possible, so that these cases become, hopefully not too messy. And because even in an exam situation, I think getting sometimes the options will not be random, like it's not one correct option and 3 other random numbers. Often the other numbers or the other solutions would be based on other approaches that people may have tried, but are, kind of wrong because they either miss a case or they overcount. So these are the kinds of things that it's worth getting some practice in. And please do solve the weekly assignments, even though I noticed that sometimes the assignment deadlines are pushed back. I would strongly recommend trying to stay on schedule so that, whenever the weekly videos are released or whenever it's week number X, you are focused on the material for that week, I think, as opposed to having a backlog from before. Of course, if you have unavoidable circumstances, if you have other things that are important in your college or in your job or whatever, I think there's enough buffer that you can catch up. But in general, to the extent possible, just try to keep up with the weekly schedule. I think that will really help, not be too overwhelmed by sort of the materials and the assignments in some sense. And of course, all of you probably already know about the forum, and you're already active there, so please do make use of that. To interact with us. It's the other way that's much more frequent. I think we try to check in on a daily basis. So I think that's going to be more continuous interaction, and we'll try to have these live sessions as frequently as we can to make more contact. So
yeah, there has not been any questions so far, but I have been asking on the live session. So Pratik Kumar says he has a question.
Right. So do you want to take that? How would I prepare for aptitude, especially for placement? So
yeah, so how would I prepare for aptitude, especially for placement? So Pratik, in general, I would like to put it this way. Discrete math is all. This is what I have got from my students. The feedback that we generally get is discrete math help them in their placements. In what sense? I always wondered. In the following sense that, see, if you want to play football, you should get your the right muscles in the right place, and you cannot do that in the football ground. You should probably do it in the gym or in a fitness club, right? Similarly, I would also see discrete math. This is a parallel help, secondary help of discrete math. Primary being it helps us do computing and analyze our algorithms. Well, the secondary advantage is, especially for students like you all, it helps you develop the aptitude muscle, right? Most of the questions there are aptitude questions, as you know. So that way it will definitely help, but not just the course. You should probably solve more exercise problems based on the content of the course, right? That's my answer for the first question. Second is, sir, is the course helpful for GATE preparation? Absolutely, Neeraj. As you know, a good chunk of questions in GATE appear in algorithms, discrete math, data structures, and theory of computation, if I'm not wrong, right? I mean, at least 30% of the syllabus is this, maybe even more sometimes. So discrete maths, I would say, is the soul of all these subjects. If you do well in discrete mathematics, you understand algorithms well. Most questions in GATE are numerical. By numerical, I mean, let's say some math will be there, and the math will, the guiding force for the math will be discrete mathematics. So Neeldhara, maybe you can also add to these questions. Anyways, nice tips there, Neil, on assignments and handling the forum and in general the subject and things like that. So what we can also do is, just in case there are not many questions, we can have an interactive mode. So I will try to ask FAQ to Professor Neeldhara, and maybe even vice versa at times, and we can make it interactive. So on to you, Neil.
Yeah, that sounds like a fun format. Sure. So no, I agree. I think in terms of preparation, I guess, yeah, the only other thing is just practice, which you've already covered. I think the assignments from this course should be a helpful starting point, but in general, the more you practice, I think the better prepared you are. So the only thing that you have to worry about is how do you structure your practice and how do you divide your time between the different materials that are there in the syllabus. I think there's a whole host of advice that's specific to specific exams. So I don't really know very much about the specifics, but I do know that there is a lot of good advice out there, and there are groups. And I mean, again, the general advice would be to just manage your time well and see if you can get a learning partner or an accountability buddy or whatever you would like to call it, or see if you can join a group that studies together with the same end goal in mind. Some of these things do help help make you more disciplined. I think left to ourselves, we tend to, find it a bit difficult to stick to something. So I think some of this might help in terms of general preparation advice. In terms of GATE syllabus, yeah, I believe discrete math is very relevant to the syllabus. Of course, it's not all of it, but it's some of it. So this should help in that sense for sure. So, okay, so since Professor Sudarshan has said he's open to questions from people on the call, so what's your favorite topic in this course? Sudarshan? What did you have the most fun explaining?
Yeah, I have always failed to realize what's my favorite topic, because every time I read a chapter, I felt there's more fun stuff than what I saw the previous time. So that way, the subjects I have read more in discrete math is definitely graph theory, which goes without saying is anybody's favorite. The moment you start seeing the initial few results, you sort of fall in love with the subject, and there's more to do there. Very quickly, you can get to a research question in graph theory that is probably not yet attempted. And that's one fun reason why this is also a popular topic amongst researchers, PhD candidates, especially in pure graph theory, because it's quick to ask and sort of not so difficult to answer as well, at least some parts of the question. So graph theory, of course, and definitely Catalan numbers. I mean, I have, it has always mesmerized me on how it just like that pops up everywhere, sort of all pervading, right? So this
yeah, Catalan numbers are just mind-blowing, absolutely. Yeah, and on graphs are always...
Yeah, I think even generating functions, I don't know how Euler came out with it. I would never come out with it for a century's time. It's so counterintuitive how a sequence can be captured in terms of a closed form which has a power series expansion, whose coefficients are the sequence you're after. I mean, it's so counterintuitive, right? At least for me. Yeah.
Generating functions and probabilistic method just feel like some kind of black magic, like it just falls out of nowhere and you don't know why it works, but it does. And then once you get the hang of it, I guess it's a great tool to apply in a specific setting. Once you know that that's the framework and it works. So yeah, very cool topics. I think all of this is coming up in the course. So I think those who are listening and wondering what this is all about, you're going to encounter, I think, all of this as we go along. I guess, is there a puzzle that you want to share, a favorite puzzle that you want to share with those who are listening to this now or later? I know you had one on your channel that I'm still thinking about. So either that one or anything else that comes to your mind.
So my favorite question has been these two. Two questions, if you may allow. First is, it's a graph theory question. Some questions are easy to ask, easy to understand, and the solution is also very easy, but it's very tough to come out with the solution. This is one such question. If you take, let's say, any graph, I don't think it's fair for me to ask this question here because graphs are not yet covered, but this is pretty straightforward. By graphs, I mean a friendship network. A bunch of people and there are friendships between them. Can we show that the number of friends that people have is not always unique? By that I mean a graph G with all nodes having different degree is impossible. Okay, so the moment someone hears this question, you start writing the answer, attempting an answer, and you realize that, I mean, why is it not happening? This looks so simple, it should be possible. But then it is governed by a very powerful principle, yet very easy, straightforward, rather obvious principle called the pigeonhole principle. Okay, we are discussing this in one of our video sessions, but this happens to be my favorite, more at the philosophical level, that here is a question easy to understand, here is an answer that's so trivial, but very tough to come out with the answer. By that I mean, see, if I give you a plus b the whole square formula and fit in a equals 1962 and b equals 7069, with some difficulty, you will be able to answer this question, right? You know very well you'll get the answer. It will take some time. Here's a question for which the answer is so trivial, but it's very difficult for you to come out with it. This has really amazed me. This is one question. And the other question that I always liked is the Monk's problem, which is the beginning part of what is called topology in mathematics. But the basis is discrete math only. The initial question is discrete math. And the question goes like this. There's a monk who starts from the foothill and reaches atop the hill, and he also comes back. He starts at 6 a.m. below the, in the foot of the hill, and goes on top at 6 p.m. Stays there for 12 hours up to next day 6 a.m. A lot of details. Please don't mind. Maybe you may have to take a note of it for you to understand what I'm saying. 6 a.m. foothill, 6 p.m. atop the hill, 12 hours of stay there, and 6 a.m. he starts from the top of the hill, and 6 p.m. he reaches the foot of the hill. Please note 6 a.m., 6 p.m., 6 a.m., 6 p.m. The question is, show that there is a step in this walkway. There's a place where the monk is at the same point at the same time, both while climbing up and climbing down. Another question which is so counterintuitive, but there are two brilliant solutions. Seemingly unrelated solutions to this question. And one question is one answer is being studied by psychologists. I'll give you more details probably offline. I'll send you the link to the problem. These two are my favorite questions, Neil, in discrete math. So if I may ask you one question, Dr. Neil. So my question is, unless you wanted to comment something on this puzzles, you can, and you can answer the question which I'm going to ask on the behalf of all the students. There are two classes of students here. There are three classes. One class is they would want to take up the course because it's sort of compulsory, or they want to learn and stuff like that. The other class is they want more math. Computer science has been an accident for them. They have joined, but they missed the math that they did in 11th, 12th, or in general, maybe Olympiad and things like that. And they're hungry for more, right? Their question is, how can we learn more? You said probabilistic method, which we actually don't cover in the course. What if they want to understand more of probabilistic methods, or more of graph probabilistic models in graph theory, right? The second class of students. Third class of students are teachers, which actually happen to be sort of our favorite, NPTEL's favorite at least, because training the teachers has been one of the important motives of NPTEL, and they have done a fairly good job in training the teachers. So these teachers continuously keep asking this question on how to make discrete math easy. All right, so many questions there. Don't worry if you miss on some, I will reiterate the question. So go on.
Sure. I guess the first piece there was for the second category of students. I mean, for the first category, those of you who are doing this out of some sense of compulsion, I can only hope that you find the fun in this, even though you're doing it because of some obligation. I think there's been a lot of effort that's gone into, I think the TAs who were involved in the course originally have put out a bunch of supplementary content, which I think is totally, it's super engaging. So hopefully you have a chance to walk through all of the core material as well as the tutorial videos. And I think at some point, even if it started out as something that you had to do compulsively, hopefully it'll end up being something that you just look forward to coming back to, even if you didn't have to for any specific reason, just because it's just so much fun. I mean, if it matches your tastes and the way you think about things, the way you like to think about things, I'm sure it's something that you will come back to for good. For those of you looking to go a little bit beyond the course, I think there's a lot of great resources. And again, it's probably more suitable to put up some of these offline. But I think even on YouTube, there's a lot of great material that elaborates on some of these things that we had mentioned, whether it's probabilistic models and graphs or the probabilistic method. I think some of it may even be addressed in other NPTEL courses that you could do as follow-up courses after this one. I think there's a course already by Professor Sudarshan. So if you liked your graphs portion in discrete math, I think probably social networks is a very natural follow-up course to take on. And there is, I don't know if it's a new course, but there's definitely a course on combinatorics, which is sort of a level up on discrete math and is again offered on NPTEL. So that is also something that you could look into. And of course, there's like no doubt of like amazing books and YouTube channels and specific videos So we'll definitely link to some of these, and maybe you are aware of some resources that you want to share with us. So please use the mailing list for that kind of exchange of information. I think that would be really cool. And for teachers who are looking to maybe spice up the discrete math experience in a classroom setting, when I was teaching discrete math last semester, I think it was basically this semester last year. One thing, actually I'm mistaken about that. I think it was the January semester, but in any case, one thing that was interesting to do in the tutorials, I think, is to talk about card tricks. So there is this really wonderful book called Magical Mathematics, I think. And again, I'll try to drop a reference in the mailing list. It's by Graham, and I believe maybe Graham and another author, so I should double check that. So that's a book that we used as a sort of a supplementary. Yeah, it's Diaconis and Graham. So Percy Diaconis is, I think, primarily a statistician, and Graham, of course, is a combinatorialist. And I think both of them are, more broadly speaking, just like amazing mathematicians on their own right. But they're also just so wonderful with exposition, and they both have a lot of experience with performing, and I think they bring in a lot of that experience into this book. So there's a bunch of magic tricks that are rooted in math, and fortunately you don't need any sleight of hand, or you don't need to be good with like tricking people to be able to perform these tricks. The reason they work is because of certain math principles, and most of them are definitely in the spirit of what you would see in a discrete math course. So just incorporating some activities like that. I mean, card tricks are my favorite, but I'm sure you can also find other real world things to do that sort of explain discrete math principles. So I'm a big fan of examples and experiences in the teaching learning experience. So I think including some of these would probably make the concepts a little more concrete and more fun to remember because you've seen it in a fun context. So I hope some of that random rambling helps and is relevant to your questions, Sudarshan. Yeah, I mean,
very nice. So, Neeldhara, maybe we can make it interactive if you want. But at times when we go on longish, then maybe we can switch off the video because in the interview mode it helps if we both sort of do back and forth. Meanwhile, there's a question here which is sort of very nice. Saransh says, sort of a frequently asked question for which even I'm yet to find the answer. He says, in probability, I do understand individual concept, but when it comes to solving exercise randomly, somehow I find myself not comfortable. I do mistakes. How to improve, says Saransh. And I'm sure you also sort of second what I'm saying. It's generally the dilemma of many people who work in mathematics related fields, that there is no one formula that fits, one size that fits all. Right? There's no one formula that will help us solve all problems. In fact, there is one problem that is my favorite in probability till date. I don't remember the solution. Every time I see this question, I feel I should solve it afresh, and I struggle. I stumble. Okay, so I'll tell you that question. The question is: given three integers, tell me if there is a triangle on it. Okay, let's say integers 1, 1, 1. Okay. There is obviously a triangle on it, the equilateral triangle 1, 1, 1. But if you give me 1 to 10, there's no triangle on it. 1 with side 1, with side 2, 2 let's say, and with side 10. There cannot be a triangle on it. Commonsensically speaking, even anyone who doesn't understand math can see the point here. You cannot fit. The maximum that you can go on the other side is 3 because 1 plus 2 is 3. That's called the triangular inequality, to use the jargon. Yeah, so but given 3 numbers, what is the probability that there's a triangle on it? The word probability came, right? So this isn't an easy question to answer, and I have had this question, Saransh, that is there a sort of a magical way that we can solve all questions? Of course, by practice we can keep increasing the sample space of questions we can answer, but we cannot exhaust the sample space. So the key probably is, so what do you say, Neil? Don't you think we all face this problem or is there a short way of doing well in probability questions?
Yeah, I wish there was. And if somebody finds out, then please let me know. But yeah, no, I completely agree. I think a lot of it is a bit of trial and error and takes some getting used to. I think doing some solved exercises in the early stages or just discussing with somebody after you've gotten a certain distance, but you haven't solved it yet. I think all of these help. But again, the short answer is in some sense the long one. I mean, which is to just practice. That's the long route, I guess. Just have to keep at it. But I think the more examples you see of problems being worked out, and in due course, you want to increase the set of problems that you've worked out yourself to build confidence. But initially, I think it probably helps. I think there are books that are dedicated to problem solving methods. They try to categorize some standard ways in which you can try to approach a problem. And all of these are generally helpful. You could start off with a book like, how to solve it or something like this. It's not specific to probability. I don't know of examples as specific to probability, but again, probability is something that shows up in the Math Olympiad syllabus as well. And there are lots of books that, help you prepare for exams like the Math Olympiad. So if you're really keen on sharpening your problem solving skills, you could try to start from there. If you search for Lockdown Math, that's a playlist by Grant Sanderson. If you search for that on YouTube, unfortunately, if I post a link in the live chat, it doesn't show up. YouTube tends to just absorb those links and not post them. So that's why I'm suggesting this way of finding the video I'm talking about. So the last video in this playlist talks about 10 tips for problem solving at large. Again, not a one-shot formula by any means, but just some helpful advice for how to tackle problems in general. And so starting with advice like that and getting a lot of practice for yourself, I think between that somewhere things will start improving and you'll start to feel more confident, I think.
Also, I did not study probability throughout my undergrad and postgrad for some reason. I don't know. So probably till date, pure mathematicians consider probability as a subject that is a trivial corollary of real analysis or something. It used to be the case historically. Also, if you know, Albert Einstein said God doesn't play dice with the world. The moment people started using physics, in the lens of probability, I think he did not like it. Or at least that's what I have understood from his God doesn't play dice with the world. And this book especially was an eye-opener for me, which I have posted on the live chat. I have posted the link to Amazon, but it is in no way an advertisement for the book. I just thought people can take a look at it and even buy it if you want. Slightly on the costlier side, I don't know why it's 33,000, but I had a Kindle version, if I remember it right. The great introduction for probability, historical introduction, as well as beautiful anecdotes and some problems too. Sort of after this, reading probability became very easy for me. So I could see the missing pieces fit in. Yeah, I agree with Neil. As and always, it's difficult to probability indeed is a very weird kind of subject. At least for me, the word weird, I mean very positively. Weird as in it doesn't fall. It is not like linear algebra. Right, you start from one end and gradually ideas develop. At least I cannot say it like linear algebra. It is, you get to have a sort of a different brain region for probability. As they say, quantum mechanics, not everyone can do it. Probability also looks like it takes a lot of practice for you to get used to what is what. Till date, I am very uncomfortable, if I may confess, with all the random variable symbols, expectation. Unless I get the intuition, I don't get any of these things, right? In fact, even when I'm attempting some proof, I do it my way, the intuitive way, and then try to convert it with an expert's help. What is X, Y, expectation, standard deviation and stuff like that. But that said, I mean, each one to himself, probably. Some people like it the rigorous way. I'm sure Neeldhara would say that, being a hardcore math person herself, but I never felt comfortable with probability. Saransh, I sense that is what you're trying to mean there too, if I'm not wrong. Right, so there's no, every problem appears like a new, it takes a new subject to solve it. Right, so I have faced this problem too. So anyways, there are no more questions here. Feel free to ask us more questions. But I have a question to Neil, more of a dilemmatic question, which the entire subject is facing today. I'm talking in the interest of some of the teachers in the course. Why discrete math has developed leaps and bounds for the past 20-30 years. unfortunately, the books haven't. That standard textbooks prescribed for this course, as you know, are quite old. Okay, or at least that's what I think. Okay, maybe there's no problem with it. The basics, fundamentals remain the same always. Goes without saying. But then there are some strong tools developed on the other side of the subject, like let's say decision trees, random forests, okay, support vector machines in machine learning, artificial intelligence areas, right, and neural networks, right. There is good amount of discrete math happening here, right. So if we talk about functions in discrete mathematics, but never do we introduce sigmoid function. If I were to be a author today, I will definitely end the chapter with sigmoid functions and a quick intro to what's a neural network and how that is also a function, right? And some taste of linear algebra. Initially, we thought linear algebra is not used anywhere in computer science except for optimization. That's a different subject altogether. Let's not touch it. We'll just use it. We'll just, we have linear solvers, quadratic solvers. We'll just, whenever we encounter that, we will put that here. And Corman was more or less one of those authors who tried including linear programming for the first time. Otherwise, the subject is atheistic towards continuous mathematics, while we are using more and more continuous mathematics. Do you think as teachers, they should also do a little more of math than discrete math to feel comfortable with computer science?
Yeah, I mean, I think you're absolutely right that with the ways computer science has evolved, especially in the last decade or so, I think a lot of ideas have suddenly become, relevant. And we can certainly use an upgrade to the kind of examples that are there in the traditional texts so that you make more connections with these more modern areas of computer science. Of course, the thing is that there are probably enough courses on AI, ML, data science, and so on. So even though it's very tempting to see that the examples there, I think that could definitely increase people's confidence in why they need discrete math, because they see that it shows up in all of these other places that they might be looking forward to going to. But on the other hand, as you were saying in the beginning also, sometimes just doing it for its own sake is also great fun. But yeah, so I have mixed feelings about it. I think on the one hand, some of these examples could definitely be useful. So if you're an enterprising teacher and you're aware of some of these other interesting examples that are relevant to DM, I would say by all means, please include them in your classroom teaching. It's probably time for a refresh on the textbooks front. Maybe we can all persuade Professor Sudarshan to consider writing a new one or teaching Discrete Math 2.0 on NPTEL. I know we've discussed this possibility before. There's definitely enough room and enough topics and enough motivation for a follow-up course, like topics like the probabilistic method and linear algebra definitely are wanting. So
dynamic author and a co-teacher like you, if you
this should definitely be fun to explore. But yeah, I mean, as of now, I think things are frankly a bit fragmented. So for the teachers, I think there's a lot of good opportunity. There probably isn't a systematic resource, but every time you see something interesting, please bookmark it for yourself, and please see if you can incorporate it in your next run of discrete math for sure. So, okay, Ashish Maiti has a follow-up question. Is it necessary to having books for learning? Can't I just watch the lectures? So I think it's a question directed at you. I'll just briefly say that it's not essential. And I think the lectures are self-contained and there are lecture notes. So by and large, you should be sorted. But books definitely are helpful sort of supplementary resource and help you dig a little bit deeper if you're interested. But if you want sort of, if you're asking, are the lectures enough? The question is enough for what? I mean, in terms of being prepared for the certification exam at the end of this course, I would say yes. But if you want to learn a little bit more, then books can be a great place to expand your sort of experience. But I think I should let you take that really.
Okay, so yeah, Neil, you're right. In fact, it's flattering to know that the lectures are enough and there's no requirement for the book. But I would also like to add, it depends on one's style. As you are like, some people would want to read it the font way, right? And slowly in the slow pace of going back forth with the letters and things like that. So it's okay to refer to the couple of books that we refer for the course. One is Rosen, second one is Grimaldi. I think we make it clear in the first few weeks. In case it's not clear, let me just type it out on the chat window. One, the author's name is Ralph P. Grimaldi. Both are named Discrete Maths only. And the other one is Kenneth Rosen. This should be enough. If you say Discrete Math Grimaldi, you will get it. Okay, so that said, coming to do we need notes is something that we get a lot in PITL. I would say, let's say we also offer another course called Python. In Python, this has been the question, give us notes and stuff like that, because that sort of is how do I put it? I feel today notes is not required because there are tons and tons of resources online. It's good for us to what is called this is called spiral learning. You keep getting lost in the information online, and then you make your own notes. I think that's easier than one textbook that you can refer to. That said, I think we have made attempts to develop notes as part of this course from the student side. Okay, sort of a collaborative notes, crowdsourced notes. Everybody comes and contributes there, and we will mostly compile it very soon and then post it online. We have it ready actually, but yeah, so it will not be complete. So we'll complete it and post it online. But you people feel free to get together, create your own notes, or at least give links to the nice resources somewhere on the internet. Or see, there's no one author who has done justice to all the topics. Different authors do well with different chapters, and some chapters are best explained online, as you know. So it is good for you to actually refer to. We are in the internet era, we should make the best use of it. Textbooks are okay to have them once in a while to solve exercise problems and things like that. We refer them to give you questions in the exam, so you should refer to them. But otherwise, the era of textbook being the Bible is long gone. Right. So yeah, as Neil says, we should be able to write a book based on the course, right? And also, yeah, I must tell you, as for the content of the course, it is a watered down version of what I teach in my IIT, in a place where I work, right? Because it's the syllabus is 20-25% omitted. For instance, in groups, in algebra, we cover a lot more. We cover this new topic called number theory, which is not even touched in our course. But then different people see discrete mathematics differently. So any syllabus of any university, if you take in India, I think we cover at least 80% of it. But taking all possible syllabus in India and then taking the union of all of them, the language of set theory, and then covering all of it will take a lot of time. It's easily 40-50 hour course. Maybe we should do a discrete math 2 for it. Right. But that said, a good course that complements our course is Ashish Chowdhury's course, which is recently released. He's a professor from IIIT Bangalore, and he has given a very nice course, topics of which we have not covered. At least 20% of what he teaches, 25% we have not covered. For instance, number theory we have not covered. Algebra we have not covered. So it's good for you to supplement from other courses too. Okay, but as with this course, if you are worried about textbook to prepare for your exams of this course, I would say you didn't break your head much. We are going to keep, as Neil said, it's self-contained. The course is self-contained in the sense that you watch all the videos, make your share of notes. That should be enough for you to do well in your exam. Okay, so if there are no further questions, I found this very interesting and it shows a lot of effort. Thank you, Saransh. Thank you for the feedback. Maybe I have been asking Neil questions, so Neil can also ask some questions too. And we can just like that make it interactive. So Neil, you're to answer your favorite topic from discrete mathematics, and not so favorites too. That will be more interesting.
Yeah, that would be interesting. Let me check if yeah. So I'm not on mute. Right. So favorite topics for me, yeah, very hard to pick because they all seem so cool on their own right. But I'm always surprised by how widely applicable pigeonhole principle is. So that's definitely one of my favorites to think about. It's just a really surprisingly simple thing. You wouldn't think that it would mean very much, but I think one of your first question was an application of pigeonholing, and a lot of mysterious statements like that don't seem to have anything to do with anything can be broken down by just this kind of observation, which is really fun. I don't think I have a least favorite topic. I have to confess that I used to be fairly scared of generating functions, but I think over time I've gotten used to making friends with them, I think, and I'm beginning to see like the charm of it. So So yeah, those would be my two topics. And I think you have already given everyone enough food for thought, so I don't want to burden the stream with more puzzles. If you really need some, then the assignments, I think, have plenty of them, so that would be a good place to get some practice. But yeah, I think your two questions should hopefully, in fact, three, because I think you also came up with a probability puzzle on the fly. So I think that's already a lot of food for thought, I think. So yeah, just trying to check if there are any more questions. And I think, yeah, I would also like to just say thanks to Saransh for joining us and for the feedback. So I appreciate it.
So another 5 minutes, and in that case, we can sort of wind up if there are no more questions. Yeah, so it will be sort of nice for us to discuss some of our experiences in the classroom or with this course online, on some topics in discrete mathematics. You have taught the subject, I have taught the subject. So have you had any sort of strange experience? Let's say, now I have had this experience when I was teaching birthday paradox in discrete math, which happens to be another favorite topic, where you go to a classroom, you ask students, what is your birthday? And you will definitely see two people having the same birthday. Okay. I remember back in 2004, when I was a lecturer in an engineering college, I remember a girl student standing up and then saying, "Sir, this is quite obvious. Why do you want to derive it so much? I mean, using all calculus and whatnot. I mean, the derivation is not so straightforward. You need to, you'll get a big n choose r formula to estimate it. It's a very big number. You don't want to estimate it because there's a denominator too. You want to just know the fraction. What helps you is a small technique from physics, where you bring in 1 plus 1 by n whole to the n is 1 minus 1 by n whole to the n is 1 by e. Anyways, details aside, she stands up and says, "Why do so much of take so much of trouble? It's so obvious for me," she says. I wonder, what is so obvious to you? And she says, "Sir, in 60 people sitting in the classroom with 365 possible birthdays, okay, you're getting a collision. But I have been seeing all my life that with around 10,000 Hindu names, okay, whatever. I mean, by Hindu names, I mean a lot of, we generally name people based on the God's name and things like that, right? With so many variety of names available in India, Indian names rather, there's always an overlap in a class. You will see two people with the same name almost always. I have never gotten into a class but I don't know two people with the same name. Why are you surprised when you have 365 names, you get a collision? I see that with 10,000 names, we are getting a collision. I mean, that was really mesmerizing for me to observe that she has noted this, and that's a proof rather, right? It's more like a, this is called sandwich theorem, right, Neil? Where you show that if A is less than B and B is less than C, then A is less than C, transitivity. So she said, if this is true, this is even more stronger. Why not use this as a logic to prove this? That's a very innocent thought that the student got, which I think once you see the mathematical proof, you will not get such nice thoughts. It's like intuition is all lost. This is one of the good experiences I had, which I don't think I'll ever forget. Another experience was with the, what's that lemma's name? Erdős-Zsekers.
Yeah. If you're looking at the monotone thing.
Monotone, yeah. N square plus 1 numbers, n plus 1 will be ascending or descending. Anyway, it's too technical to discuss, but that's a very, very elegant question, which many students remember. One question that I've been asking my students after they graduate is when they come and say, "Sir, we had fun with discrete mathematics." When I ask them, "Do you remember anything in discrete mathematics?" They say no. But the course was fun. But one thing they all remember is the Erdős-Zsekers result. That it's so sort of, it's a piece of poetry, so beautifully given, especially in Grimaldi. The proof in Grimaldi is really splendid, and we cover that too in the course. I think I remember it right. Yeah, we do cover. I think people should take a look at it. That is where math comes close to literature. And that one thing students do remember, surprisingly. I don't know why. That's probably the toughest, but students still remember, probably because it's very early.
Yeah, I think the statement itself is also a bit surprising. And yeah, it's an elegant fact for sure. Maybe that's partly why. And I think you again use some kind of pigeonholing to prove it, if I remember correctly. Like you have to set up something clever and something interesting there for sure. Yeah, I think maybe this is a recency bias, but I think the last time I did this was with the magic tricks. So I think the sense of satisfaction that people had when they figured out what the magic was, with even before we revealed the trick to them, I think that sense of yeah, also confidence that you could figure it out. I think that that was really interesting to see. So I wouldn't say that it happened with everybody, but at least a couple of people would typically figure out what was going on. And once again, if you are interested at all in magic broadly or card magic in particular, definitely look up Magical Mathematics. I think it's a really great resource for such things. And there's some pretty non-trivial math driving all of that phenomenon. So I think it's a great mix of like puzzles, trickery, things that would make for good evening entertainment at home, even with people who don't care about math. But for yourself, if you're listening to this, you probably do care about the math, and it's a great exercise to figure out the behind the scenes as well. So yeah, so all in all, I would say that that would be some of my favorite experiences came from the tutorials where we were fooling around with this kind of thing. Yeah.
Wonderful. So I think we can sort of go on and on. There's a lot to talk about discrete math. In fact, if we take a problem and then start, writing and discussing it, I mean, the sequence, at least it gets even more interesting. Probably we'll do that in the upcoming sessions, one problem per session and things like that. This is better than what I thought, Dr. Neil, and I'm sure students enjoyed the interactive mode of two instructors coming and talking. It helps when there are not many questions on the, on the chat window. We can ask each other questions and make it an interactive interview style thing. I hope people who are watching the recorded session enjoyed the session. If you have anything more, Neil, we can talk and wind up. Maybe
yeah, I mean, I'm good. Yeah, I'd just like to thank everyone who attended, and hopefully, as you said, people who watched the recorded session get some value out of it. And for the future sessions, I think we could plan to discuss some more specific ideas. But since this was the first one, I think it was just nice to keep it general. It was nice meeting everybody who was here in the chat. So so have a great day, everyone. A good weekend, and I think we will continue the conversation in the mailing list and in the next live stream, I guess.
A small and quick announcement, which may even help you, Dr. Neil. I'm unsure whether you are aware of the fact that NPTEL actually provides internships. It has taken a backseat lately given the COVID related crisis, but NPTEL would generously offer many students to go and intern with the professor of their choice, provided they secure a certificate with gold or silver. I don't remember it right, but there is some criteria which can be easily met. I mean, many students do meet the criteria. And if you have met the criteria, you can go to the professor, interact with the professor, stay with the professor for 1 or 2 in the institute for 1 or 2 months, do your internship, and then come back. It's a proper internship possibility. So please talk to us, write to us in case you're interested in the subject and you want to do more in the subject. Okay, we'll be happy to consider you for internship. Both me and Neeldhara, both our institutes are. We have a very very dynamic internship program that has again taken a backseat because of COVID. But yeah, we are doing it online right now. Makes a huge difference. Online is not fun. We all know that. But yeah, this possibility is there. It's even paid. You get your TA, DA, and some fellowship to stay in the place. So Dr. Neil, I'm sure Neil also offers competitive programming course for the first time on NPTEL. I would say for the first time in India, from an academic background, someone has offered competitive programming course. You all should take it up. It's a very nice introduction to algorithms too, the hands-on way. I'm sure you can connect discrete math with that very quickly. If you want applications, I mean, that's the destination. Better even do it parallelly. Of course, the course registrations are now closed, but nothing stops you from looking at the playing list. And maybe Neil, you can share the playing list on the mailing list.
Yeah, thanks so much for the mention. Absolutely, I'll do that. You're very welcome to follow along with the materials and join the community as well. The only thing you won't be able to do if you're not already enrolled is give the exam. You can always do that next time. So yeah, the exams and the assignments, in case you're not around, you could enroll in the next edition. But yeah, thanks so much for mentioning that. It has a very similar flavor in terms of puzzling things out, but the only difference is that it's a little more implementation oriented. So we'll be doing a lot more coding there. But yeah. So yeah, once again, I think we just, we could wind this down at this point. I don't see any other questions, but yeah, I would like to thank everyone again, and we'll see you hopefully in a couple of weeks, in a few weeks, sometime in September, I guess.
Sure, wonderful. So we can have this session maybe once more whenever there. I think there's not much of students who have turned up today, mainly because the short notice with which we planned everything. But I think the next time we'll plan it at least a week in advance. Okay. Thank you all very much. Wonderful joining us, Neel and Saraswati, as well as Harshil, the TAs of the course. Next time onwards, maybe you guys can also come and say hi to the students, because they are the ones who interact with you more than us. Okay, chalo, take care. Bye bye. Have a nice weekend, all of you.
Yeah, bye everyone. So I think we could stop.
Yeah, we could stop now.
Stop the streaming, sir.
You can